Okay, so today we are revising about different concepts of the Dockers we have seen so far. So to start with, Docker basically consists of these components. So we have a Docker CLI. So Docker CLI is nothing but this Docker commands which we execute. So let's say Docker container ps. So this basically is a Docker CLI. Okay. Then we have a Docker image. So Docker image is nothing but a file system or a different files which makes our application, that is Docker image. And then Docker CLI provides us with different commands, using which we can list the running containers, different images we have on our system, right? So that is Docker CLI. Using Docker CLI, whatever the commands we execute, that are sent to a Docker runtime which has Docker daemon, right? And Docker container is nothing but a running instance of an image. So when you run a container, it creates a small machine which gets all the files from a particular Docker image, and then with the help of that container we can run a instance of our application, right? So that is what basically the Docker main concepts are. Then let's talk about the different Docker commands. So I have listed down here the different Docker commands. So let's start with this. This Docker build commands we will see once we will start looking into the Docker file and how to create our own Docker images. We will look into it, these commands, when we will talk about that. But about this, like if let's say I want to check what different Docker images I have on my system, so I will run docker image ls. So we can see I have got these many Docker images on my system, right? If I want to check the running containers, so it's about different commands. When you want to use Dockers, so you should be aware of these commands. So Docker container ps, so this will give us the list of running containers, okay, the containers which are in running state. And if I want to see all the containers running as well as stopped, so I would say docker container ps -a. So this will give me the list of all the containers. Now we can see here these are the two containers which are in the exited state, means which are in the stopped state. So that's the reason why I didn't see anything when I executed docker container ps. I don't have any container in the running state. Now if we want to start a already stopped container, a command is docker container start and name of the container. So I will give a name Nexus, as well as let's say I want to start Jenkins also. Both of these stopped containers I want to start. Right, so now we can see here these containers are up now. The status is up now. So here we can see the container ID, which is a unique ID for each container. This is the Docker image which the container is using. This is the command of the container. We will talk about this command when we will create our own Docker images. That time we will discuss this. This up status is since when the container is in running state. this is when it has been created. So created container and running container do different things. This container was created 24 hours ago. Just yesterday in the session I had created this container, so it is showing me the created 24 hours ago, but I just started this just now, few seconds back, so it is showing me the status app as up since last 6 seconds. Then these are the ports. We will talk about this again, the ports, port forwarding and port publishing. So this ports it is publishing, this is also right. Now this is the command docker container ps. Another command which is very important is if I want to check the logs of a particular container. So it's all about commands in the initial stages, right? So if I want to, let's say, check the logs of this container Nexus, so I would say docker container logs Nexus. So I can check the logs of that particular container. So I can see the Sonatype server is up and running. If I want to check the logs of Jenkins container, I can say docker container logs Jenkins, name of the container, and these are the logs of my Jenkins container, right? Now let's move on to the next commands here. So just now we talked about this docker container ps, docker container ps-a, logs and inspect. Now let's understand this inspect command. Now if you want to actually inspect different details of a particular container, the one which are not shown here, anyways the basic details of the container are shown here, but if you want to see those details of a container which are not shown here but you want to understand few more details about it, then you can say docker container inspect, and then you can provide a name of a container. Now here we see lot more information about a particular container. Say for example, I'll just go up and let's say environment variables. So here I can see the environment variable set to this container, the particular one, right? This information I can see. Then I can also see details like mounting, which mounts am I using. So I am using this mount destination Nexus data. This is the directory from the container I am mounting, right? Then I can see other details also. Let's see those. Port bindings, I can see which ports I am binding. So this is the internal port 8081, I am binding to 8084. Internal port 8085, I am binding to external port 8085. So all the details about the container.
Can you just explain once again regarding these ports that like from where we are?
Correct. I'll be. Just in the next command, when we will see the DockerRun command, I'll explain you about the port binding again. Okay, now let's talk about DockerRun command. Basically, DockerRun command is the command which we use to create and run container. Both the things happen. So let's take an example of this command and let's see what this command is. Okay, see here. Now this command, this DockerRun, which we use to create a container using an image. Okay, so DockerRun. Then we will talk about this -d a little later, but dash name and this name. So this gives the container a name. If we don't give our own name, then some kind of a random name is chosen for a container which would be created. -v is for volumes. Now what are volumes? Let's understand, and then we will talk about these two settings, main settings. Okay, let's understand but what are volumes. Basically in a container, let's say Docker container ps. Okay, now inside this container, the one which has been created, this container has got different files. So those files, they are part of the image. The default file system comes along with the image. So it's like when you install Jenkins on your own bare metal system, so we see few files which gets installed as a part of the installation. So the image contains that default file system, okay, which you get after installing Jenkins. Now as and when you start using Jenkins, you create your own data, right? Different jobs and different, let's say, configurations. So user data gets created inside the container. The point is, containers are if you delete a container, particular container, then all the data which is there inside that gets wiped out. If you have created any user defined data for that matter inside this container, and if you delete this, you will lose everything. Whatever the jobs you have created so far, whatever the configurations you have created so far, everything would be lost. Right? Now what is the solution to this? Can we preserve the data? Can we have some kind of an arrangement where I will not lose the data even if I delete the container? So the solution is volumes. Now how the volumes work, I have created a diagram for that. So we can see here, this is our machine. The square which I have shown here is a machine, Docker host machine, a machine on which you have installed Docker, okay, in simple terms. Now this is a container, this one, which is currently the highlighted one, and I have some data in this directory. So this container, if I delete this container, then the data from this location would be lost. So what I can do is, I can preserve this data on the file system of my Docker host. So this machine where I am using Docker, on this machine I can preserve the data from this location. That is called mounting. So mounting can be done for any of the location from your container to any of the location on your Docker host. The point is, even if you delete a container, still the data would be preserved and would be present on the file system of your Docker host. So as long as you have that file system location from a Docker host with you, you will not lose a data. Now if you delete this container and you have preserved the data using volumes, so there are basically mainly two types of volumes. One is the named volume and another one are bind mounts. But we have not yet seen about bind mounts, which we are going to see and talk about when we will create our own Docker files. But that is another type. But named volumes, so you get the location created on your host system to which you give some name, say Jenkins _home is the name for that location, and that location you mount that location to any of the desired location from your container. So whatever would be data which would be created inside this location in container, those contents would be also be synced. Your location from the Docker host which you have mounted, that would be synced with the data created inside the container, right? Any data if you put inside the location on the host, that also you will receive in the container. So it's a two-way syncing actually. Whatever the data would be created inside the container would be available to the location from your Docker host. Whatever the data which would be created on the Docker host would be also available inside the container, right? Now, how can we do this using a Docker run? So basically, when you are starting a container, that's what the command I have copied here. So when you are creating a container, you have to say -v volumes. You can give any name. I have given a name called Jenkins_volume. So the volume would be created and that would be mapped to this location from the container. So this location is from the container and this is the location on your Docker host, a named volume, right? So our volume first would be created. As soon as you run this command, this DockerRun command, first it will create a volume. This volume will have some location on your Docker host that we cannot choose, by the way. The location we cannot use in case of named volumes, but when we will talk about bind volumes, then we can choose a location which we want to bind or which we want to mount from our host system. But in case of named, we do not have a choice here, but some location from your Docker host would be mounted to the location from your container, right? Now let's talk about this part. What is this? So basically our Jenkins server, in case of Jenkins, our Jenkins server is running container logs. I'll show you. So our Jenkins server inside the container runs on a port 8080 actually. Okay, on a port 8080, we can see here, see 8080. So our Jenkins server is running inside the container on 8080 port. Now I have also created a diagram to show port forwarding. Let me open that. See, here it is. So our Jenkins is running on port 8080 inside the container. Now I want to access the Jenkins running inside the container. So if I say localhost :8080, then that server will not be accessible to me if I try to access it here on this my Docker host system. The square which is highlighted, it is a Docker host. This small square is a container, right? Now I want to access this. So what I need to do is, I cannot access the service running inside the container directly from my host system. What I need to do is, I need to map the port of a container on which that particular service is running. So inside the container, my Jenkins service or Jenkins server is running on port 8080. So I need to map my container's port 8080 to some port of my Docker host system. So I have chosen 8083. You can choose any port which is available. So 8083 is mapped to, So 8083 from my Docker host system is mapped to my containers 8080. So whatever the requests, now for example I would send to this 8083 would be forwarded to 8080 to my container. This is how the communication would be happening. So whatever the request, let's say on a browser, if I go in a browser and I say localhost colon 8083, so this request will first come to my Docker hosts 8083 port, which would be forwarded to my containers 8080. Whatever the response my Jenkins server will send, that response will first come to this 8080 inside the container and would be given to 8083 on my Docker host, which would be returned back to the browser, let's say. That is how the communication happens. So this is called port forwarding or port publishing. Okay, so that we have done using this -p. So what we are telling is, when we are creating a container, this particular one, so we want this Jenkins to be the name of it. We want to mount the volume to this location inside the container, and we want to port forward or mount. Let's not call mount, otherwise it would be again confusing between the directory mounting and the port, but let's say port forwarding. So I want to forward my 8080 port from the container to 8083 port of my Docker host, right? So this you have to mention at the time of creating the container only, and this is the name of your image which you want to use to create a container. This is the entire understanding of this DockerRun command, right? So if we run this, we will get our container and we will get our container running, and the port forwarding has also been configured and mount has also been configured, right? Then we talked about very important aspect, and that is environment variables. So environment variables, these are nothing but the settings which the particular application needs. So if we talk about Docker container PS. So if we talk about this Nexus, so this Nexus container runs a Nexus server. Now this Nexus server needs different settings, like where to create the user data into, then where which Java JVM options it should use to start the server. So different kinds of settings it needs. So those are nothing but environment variables. So user meaning the one who is creating a container, he can specify where he wants the user data to be created inside the container. Like different environment variables every Docker image exposes, and they give all this information on their official website. So if we check out the official website of Nexus DockerHub, so here we can check out which environment variables it needs. So here, see here, this is one environment variable, install 4j add VM params. This is one, and Nexus context is another environment variable. So there are few environment variables which this needs, this particular. You can also see, if you want to at all see like which environment variables it uses, so you can inspect as I had done previously, Docker container inspect and name of the container Nexus. If you go up and check, See here, these are the environment variables in the env. These are the environment variables. Nexus data, Sona type dir, install 4j add VM params, Sona type work. So these are the environment variables it uses. So if we wish to set our own values to these variables, so that server will take those settings which we want it to take, and then it will start with our own user defined settings. So we can set the values to these environment variables. So for that you have to run DockerRun command like this. See, DockerRun, we will talk about this detach afterwards, but dash name, this dash rm. So basically when you stop the container, once you are done with your working, now you want to stop the container. So you stop the container with the help of Docker container stop and the name, say Nexus name. So when you stop the container, a container gets stopped but it remains on the system. But if you want to now remove that container which you are no longer using, so you have to say Docker container rm stands for remove, and name of the container Nexus new, or you can also say Docker container prune. So this prune will remove all the unused containers, and this will remove a particular container, right? Now what this rm is, if you have started your container with this as an argument, so what this tells is, like, when you will stop the container, it would be auto removed. So you don't need to run either this or this to remove the stopped container. So it is auto remove. This sets the auto remove to true, right? That is what this rm is. And if you want to set the different values to environment variables, so you can do something like this. E stands for env variable, and then you can specify the name of the environment variable equal to value you want to set. Again -e, name of the second environment variable and the value you want to set, and then this is the image you want to use. So this is how you can set your own values to the environment variables inside the container. So when the container will start, it will start with these values set to the environment variables, and it will consider these values for its working, right? That is what environment variable. Now instead of sending this environment variables as a part of command, another option we have is create the separate file of environment variables. Okay, I'll show you that. We have done that also. Let me show it to you. So here, correct. So this is the env file. So what we can do is, whatever the environment variables we want to set, we can provide them in this single file. Okay, and then we have to save this file with the extension env. You can give any name. Now when you will run or create a container, you will run this DockerRun -name, say Nexus new, then -env-file. So instead of sending this environment variables as a separate argument, what you will do is, you will provide the path of this env file like this, Simple, right? So it will take all the environment variables defined in this file and will set the values defined in this file to those all environment variables. So it will save us a lot of data which we would have mentioned in the command. This we can get rid of this entire list of environment variables just by defining them in a single file, and we can send that file to this, right? So this also I have mentioned here. You can see DockerRun RM and then name and this --env file and the path of the file, right? So this also we had seen.
So Pranay, for each and every type of image which we run, so these environment variables are not necessary, right? So wherever it's necessary, only then we will have to mention either through command or through the environment file.
Correct. Exactly. That kind of an information you will find on the respective Docker image page. That official page, which environment variables are mandatory. Like for example, if you are creating an image of MS SQL database, so it is mandatory for a user, the one who is creating the container, to set the password for a database. So this environment variable is mandatory to be set, right? So this kind of information you will see from that particular official page of the Docker image.
Okay.
Right, and then we talked about Docker Compose, because see, in case of like Dockers, like if your application consists of different containers and you want to start the application, so you have to run DockerRun commands for each and every container which is part of your application. That is one. Another point, all these configuration settings means all these things like this name, then these environment variables, or these volumes, or this port forwarding, everything which you are setting as a part of DockerRun command. You can define all these configurations in a single file, and then you can create your containers using that file. That is what Docker Compose is used for. So it is basically helpful in mentioning the configuration at a single place. Another point is, if you have a multi-container application, that is, there are multiple containers you need to start while starting up your application, so you will need to run DockerRun commands for each and every container. So that effort also you can save with the help of Docker Compose. So we had created this Docker Compose. See here, this is a Docker Compose file. Services are nothing but containers. So you can give any name to your service, and all the details related to that service should go here. So which Docker image, which container name, what ports you want to expose or publish, what volumes you want to attach, which environment variable file you want to use. Similarly, for this service you can define its configurations: image, container, ports, volumes, then the environment variables. So you can just simply start a command prompt and you can say Docker Compose up, Docker Compose -f, then the location of this file, and you can say up. So it will create all the containers with this single command. You can see the difference here. I have to run this long command of DockerRun having everything mentioned, volume, port forwardings, image, name, and even environment variable for that matter. So all these configurations now I don't need to define in my DockerRun command. Those would be taken from this file, and accordingly my container would be created, right? So all the containers which you will define here in this file, they would be created in one go with a single command. If let's say I have 10 services created here, so all of those 10 services would be, all of those 10 containers would be created with a single command, which if I don't use Docker Compose, then I need to run 10 different DockerRun commands, that too with configurations defined for each container, which is quite cumbersome, which is quite error prone also, right? So it's good to define all those configurations in a file and start the container.